When we talk about area, right? Say area of this structure is, I don't know, I don't remember, maybe 24 square unit or something. We make use of the word square over here. But why? Why are we talking in terms of square unit, square centimeter, right? It can be square centimeter or square meter or square millimeter also or kilometer, whatsoever, right? Whatever shape we take, whatever we take, we always go with square of something. But why square? Why not something else is what we are trying to understand. So I just want to recap about square. Squares are your four-sided structure. This structure's speciality is that all the sides and all the angles are equal. All the sides and all the angles are equal. So basically they are measuring 90 degree over here. So if someone tells area of say some structure is say 4 square centimeter and say this is 1 square centimeter. Okay. So if I tell, I have a structure, right? Some weird structure like this. And the area is 4 square centimeter. What it means is area is equal to the area of this particular thing. The area of this particular structure is equal to the area of 4 squares whose side measures 1 centimeter. That's the whole funda. That's it. As simple as that. So basically, this is equal to me placing 4 squares next to each other whose dimension is 1 by 1. This is 1 square, this is one another square, this another square, and this another square. This 4 squares can be fit in perfectly into this. That's the funda. That's it. That's what it means. Okay. So the idea here is to get a perfect one which can be communicated. Right? If I tell 4 square, it means this. Now the question is, why not 24 circle centimeter? Why can't we use a circle? Right? That's what we are trying to figure out over here. Let's pick up any shape. So for that, we'll pick up some random shape, and that shape happens to be a circle. So we have to use the same size circle because here we are using same size square. Right? Oh, here actually this is a good example. So we can see all the squares are of same size. So instead of like square, why not circle is what we are trying to see. So for that, let me draw a circle. Say this big. Now let me copy this and let's see. Let's try to figure out, can we use this? I need to place them in this manner. Neat. Something like this. And I have to keep doing this basically. Right? So this too looks like that, square grid like the graph paper we saw over here. This too looks like that. But there is an issue. Can you see the issue? Or is there no issue at all? Is everything okay over here? What do you think? So let me see. This can be one full circle. This is one more, one more, one more, one more, one more, one more, one more. So basically I can tell this to be 1, 2, 3, 4, 5 or 3 plus 4, 6, 9, 10. This I can tell it is made up of 10 circle unit. Can I tell that? I kind of can, but there is an issue. What is the issue? Well, we are trying to figure out the area that this particular shape occupies. But between the circles itself, there's so much of space that is left out. Who will add this? There's a lot of space that is left out. Do you guys agree? Will that be a problem? Yes, it is a problem. Reason being, the area has to include everything that the shape is occupying. Basically, all of this area has to be included. But with my circle, right, the one which I've taken over here, it's missing out this, big chunk of area. And so, to conclude, it's easier to use square because they fit neatly together with no gaps or overlap, right? So you can see over here, it's proper. There's no gap between the squares and there's no overlap. What does overlap mean? Let me show that over here. This is overlap. Means if someone tells you know what, just put one set of circle over here or over here and so on and so forth. But that then we are recounting things, right? Let me actually do this. Let me make use of some other color. I don't remember exact size per se. I think this is kind of okay. Yeah. So if I do this, if someone tells me you can do this, right? Then you're occupying every unoccupied space as well. But what is happening over here? We are recounting the space. The black circle originally had occupied that space, but the red ones are reoccupying that space, so there's overlap. We won't get the exact answer. We are recounting in some way. If someone asks you to pay him or her 10 rupees, will you give them 12? No, right? I mean, whatever exact transaction should happen. Sometime you might be, chalo, we'll give them 12 or tip 13, 14. That is a different case. But if someone is asking you 100 rupees, you will pay them 100 rupees. You won't pay them extra or less. So that's what a square does. Square helps you to give that exact count that is needed to measure the area of a particular structure. While a circle or pretty much anything else, it might not lead to that. Or it might be too complicated as well. You can have structures which clearly occupies the entire space and there's no gap, but it can be complicated. So one more additional aspect about square is that it's much easier to look at, count, and so on and so forth. So with that as the idea, we make use of square unit. That is basically counting the number of squares that the particular shape can occupy. We did this exercise in the last set of videos wherein we measured irregular shapes, right? So that idea I have continued over here, and we concluded that it's best to use squares to measure areas. And also I explained one more extra bit of information, that is what does 4 square centimeter mean. So now onwards, if someone tells you 10 square centimeter or 120 square kilometer, you need to imagine that there are 120 squares whose dimension is 1 kilometer by 1 kilometer. Okay. For example, over here, this square, the square has a dimension of 1 centimeter by 1 centimeter. That's how they communicate. Okay. So there's a lot of new things that I'm teaching you guys. So it's okay if you don't get in entirety everything that I'm talking about. Slowly build it up. It's okay.